IFR training videos, by
Toga Thrust.
ADF Interceptions. Agenda. Introduction. Different interceptions. Interceptions principles. Interceptions methods. Some exercises.
Introduction.
We are facing major changes in aviation, mainly in instrument flying. With the growing importance of satellite positioning, old-fashioned navigation and approach techniques will soon become obsolete. What about pilot core competencies? Are we bound to follow the line and nothing more, or should we keep training those procedures and techniques to keep what makes a pilot, mastering? You think right if you are watching this video. Let's train as a pilot. Satellite navigation and approach techniques will be a part of your training. Different interceptions. Why are interceptions for? While navigating, you have several situations where you have to proceed with a radial interception. During cruise, when overflying a station and leaving via another radial. During approach to follow the prescribed routing. By ATC request to position yourself due traffic or other reason. When entering and holding pattern. So, there are three main types of interceptions. From QDM to QDM. From QDR to QDR. From QDM to QDR. From QDR to QDM. Intercepting a QDR after passing the station, tracking a QDM.
Interceptions principles.
If less than 1 minute away from the station, limit the attack to 20 degrees. Each QDM interception will be with an attack of 30 degrees. Each QDR interception will be with an attack of 45 degrees. Interceptions passing overhead the station will use its own angle of attack equals to 1/3 of the angle of difference, AOD. There are some special cases of interceptions we will talk about later. Always refer to the RMI needle. Always put your finger, mentally, on the head of the needle, for a QDM, and on the tail of the needle, for a QDR. The head of the RMI needle is always drifting away from the nose of the aircraft, while the tail of the RMI needle always gets closer to the nose of the aircraft.
Interceptions methods.
There are several methods used to resolve the interceptions problems, from the most complex to the most intuitive. As you have in front of you all the instruments to build a mental image of your situation, the most intuitive is, from far, the best one as it does not require complex computations. What is it made of? Simple principles, of course. Let me tell you a stupid story, involving Mary and Robert. Just remember that Mary liked to play swing. And that Robert is your best friend, he always gives you more than you want because he wants to be such a good friend. And then you say, what is this all about? Very simple, when we talk about QDM, we will think about Mary that loves to swing. And when we will talk about QDR, we will think about Robert who is so generous. And remember, we use 30 degrees for QDM, and 45 degrees for QDR. We will determine first the heading for the interception, then we will confirm with the principle seen above, saying that the head of the RMI needle is always drifting away from the nose of the aircraft and vice versa. Some simple examples: we use exclusively the RMI. Interception from QDM to QDM. On the picture, we see that our actual QDM, head of the needle, is 058 degrees. Let's say that the ATC asks us to intercept the QDM 080 degrees. We want a QDM. So Mary is entering the game. Let's swing. Put mentally your finger on the head of the needle, actual QDM 058 degrees, go to the desired QDM, 080 degrees, and swing. Go back to the actual, and continue on the other side by 30 degrees, and there you go. This is your interception heading, 028 degrees. When established on the heading, confirm you are on the correct course by confirming that, if the head of the needle is always going away from the nose of the aircraft, it will rejoin the desired QDM. Interception from QDR to QDR. On the picture, we see that our actual QDR, tail of the needle, is 254 degrees. Let's say that the ATC asks us to intercept the QDR 220 degrees. We want a QDR. So Robert is entering the game. He's a hell of a guy. Always giving you more than you want. So we want a QDR 220 degrees and are actually on the QDR 254 degrees. Let's put, mentally, the finger on the actual QDR 254 degrees and move to the desired 220 degrees. And, as Robert is always giving more, then you continue by 45 degrees in the same direction. And here is our interception heading, 175 degrees. When established on the interception heading of 175 degrees, we check that, as the tail of the RMI needle is always closing into the nose of the aircraft, it will pass by the desired 220 degrees. Interception from QDM to QDR. We apply exactly the same principle. QDR is Robert. Actual QDM is 029 degrees and ATC asks us to intercept the QDR 270 degrees. Simple. Put, mentally, your finger on the actual QDR, 209 degrees. Go to the desired 270 degrees. And continue by 45 degrees to find the intercept heading, 315 degrees. Remember, Robert is giving too much. When we are on the interception heading, we check with the usual principle that the tail of the RMI needle is always moving towards the nose of the aircraft, and we check if the needle is passing by our desired QDR. Interception from QDR to QDM. Let's make it from random position this time, not going straight to the station. We are currently on a QDR 235 degrees. ATC asks us to intercept the QDM 090 degrees. We want a QDM? Swinging Mary. What is our actual QDM? 055 degrees. What is our desired QDM? 090 degrees. Let's swing 30 degrees. Interception heading equals 025 degrees. On the heading 025 degrees, we see that, applying the principle saying that the head of the needle is always drifting away from the nose of the aircraft, the head of the needle, QDM, will pass by our target 090 degrees. Of course, you can apply those principles in any situation, flying directly to the station or not. Remember the key points. You want a QDM, Mary is playing. For a QDM, you use 30 degrees. You want a QDR, Robert is your friend. For a QDR, you use 45 degrees. When within 1 minute of the station, reduce the angle of attack to 20 degrees. Something new. On interception heading, you are in interception phase, you keep your heading unchanged until reaching 10 degrees difference between the actual and the desired radial. When reaching 10 degrees difference, you are then in tracking phase. You reduce the attack to 3 times the difference, starting then with a 30 degrees attack. Then, when reaching 5 degrees difference, the attack should be reduced to 15 degrees. And you smoothly intercept the radial without overshooting. Intercepting a QDR after passing the station tracking a QDM. This is a special case. Let's say that we are inbound to the beacon on a QDM 058 degrees. To continue our planned route, or to enter a hold, or to follow an approach routing, we have to leave the station on a QDR 120 degrees. What should we do? If we pass the station and turn to our outbound heading 120 degrees, what will happen? There is a silence cone when overflying a station, inside which there is no signal reception, so, you lose information shortly before overflying the station, and you regain signal shortly after passing the station. How long? It depends of your altitude. We can say that, if you are flying at 6,000 feet AGL, you will lose contact for 10 to 15 seconds. It is enough to place you at a certain distance from the station. So, if you turn to a heading corresponding to the QDR, you will fly parallel to the wanted radial, at a certain distance. So, you need to continue the turn to have a certain angle of attack to rejoin the wanted radial. But what angle of attack should we adopt? First of all, determine the angle of difference, AOD. Here, it is between 058 degrees and our target 120 degrees. That makes an AOD of 62 degrees, more or less 60 degrees. Take 1/3 of this AOD, that's 20 degrees. When you will make the turn, you will continue past your target for 20 degrees more. In this case the heading will be 120 degrees plus 20 degrees equals 140 degrees. Let's visualize on a short video. That's all for this interception method, simple and intuitive. There are other methods used, as in the military, ADF and DAT, see after. The SABENA S, and others you might find. Just a few words about those first two. Military, ADF and DAT. Those are acronyms for ADF, actual, desired, 45 degrees for a QDR. You go from the actual to the desired and you continue 45 degrees. DAT, desired, actual, 30 degrees for a QDM. You go from the desired to the actual and continue 30 degrees. That is very handy too, but do not confuse the two acronyms. SABENA S. This method works but is a bit complicated. For a QDM, you start at the tail of the actual bearing. Proceed to the tail of the desired and cross the instrument to the head of the desired. Proceed then to the head of the actual and apply the standard attack of 30 degrees. Which result is the twisting of Mary. Finally, there is an amortization to do when approaching the target radial to avoid overshooting it. When you reach a difference of 10 degrees between the actual and the desired, you reduce the attack at 3 times the difference, here 30 degrees. When reaching 5 degrees difference, you reduce the attack to 15 degrees. When you reach 2 degrees, reduce the attack to 6 degrees. And you finish exactly on the radial without any over or undershoot. If the difference between the actual QDM and the desired QDM is between 60 degrees and 90 degrees, here an actual of 087 degrees and a desired of 010 degrees. Take an attack of 90 degrees on the desired QDM. When the difference between the actual QDM and the desired QDM reaches 60 degrees, take an attack of 30 degrees on the actual QDM. Of course, the weak initial angle of attack will take us very close to the station when reaching the 30 degrees angle difference, and the turn will nearly be a continuous one until reaching the target radial. The risk of overshooting is quite high. If the difference between the actual QDM and the desired QDM is between 90 degrees and 180 degrees, here, the actual is 180 degrees and the desired 300 degrees, a difference of 120 degrees. Take a downwind leg, opposite heading to the required course. When a beam, chrono for 2 minutes. A beam can easily be found by looking at the railroad track on the HSI, the dot O at 90 degrees from the CDI. Once the needle is parallel to the railroad track, you are a beam. After 2 minutes, turn base leg. Base leg means taking 90 degrees on the required QDM. When A odd equals 10 degrees, tracking phase and take 30 degrees on the required. Some exercises.
The way to get started is to quit talking and begin doing. Walt Disney.
Some examples of QDM interceptions. We are tracking the QDM 300 degrees and the ATC wants us to intercept the QDM 280 degrees. We use disabled VOR CDI to visualize the desired QDM. Head of the needle is for QDM. Desired is to the left. Mary swings back to the needle and 30 degrees right, making an interception heading of 330 degrees. We are crossing the QDM 110 degrees and the ATC wants us to intercept the QDM 140 degrees. We use disabled VOR CDI to visualize the desired QDM. Head of the needle is for QDM. Desired is to the right. Mary swings back to the needle and 30 degrees left, making an interception heading of 080 degrees. We are currently on QDR 300 degrees and ATC wants us to position on QDR 330 degrees. Tail of the needle is for QDR. QDR is for Robert. Go from 300 degrees to 330 degrees and continue 45 degrees. Yes. Interception heading is 015 degrees. Now let's say that we are crossing the QDR 330 degrees. ATC asks us to intercept and follow the QDR 290 degrees. Tail of the needle is for QDR. QDR is Robert again. We go to 330 degrees, continue to 290 degrees and 45 degrees more until 245 degrees, which is our interception heading. Simple, no? Inbound to the station on a QDM 110 degrees. After overflying, we have to leave on a QDR 155 degrees. Angle of difference is 45 degrees. 1/3 of 45 degrees is 15 degrees. So we will continue the turn 15 degrees more than 155 degrees and pick a heading of 170 degrees for interception. Inbound to the station on a QDM 300 degrees. After overflying, we have to leave on a QDR 240 degrees. Angle of difference is 60 degrees. 1/3 of 60 degrees is 20 degrees. So we will continue the turn 20 degrees more than 240 degrees and pick a heading of 220 degrees for interception. To finish this module, just a little detail, but it will make your life so much easier. When you have crosswind, anticipate the rollout of your turn to take into account the crosswind component. On the Garmin 1000, you have that tiny little magenta diamond on top of your primary flight display, PFD. That little diamond is the wind bug and it shows you what is your ground track if you keep that heading. So, to track a radial with the G1000, Simply put the diamond on top of the ADF needle. As radials are ground references, the ground track will permit you to make a perfect tracking of the radial without hard computations of the crosswind. For the ones flying without G1000, no stress, just evaluate the crosswind with the wind report at your altitude and divide it by the airspeed number ASN, remember? You will obtain the correction to apply against the wind for a good tracking. Imagine the weather report gives you a wind of 40 knots from 30 degrees from your left at your flying altitude. You can evaluate grossly the crosswind to be 1/3 as it comes from 30 degrees relative to the track, 1/3 if it comes from 0 degrees to 30 degrees, 2/3 if it comes from 30 degrees to 60 degrees and 3/3 if it comes from 60 degrees to 90 degrees. So, in our case, crosswind is roughly 40 divided by 3 equals 13 knots. If your TOS is 120 knots, your ASN is 120 divided by 60 equals 2. Divide the crosswind component by the ASN, 13 divided by 2, and you then know that you have to apply a correction to the left of 6 degrees to keep your track. Then you fine-tune your correction if the needle deviates.